All right. I hope my screen is visible to everyone and I'm audible. Today we are into the 11th lecture of social media analytics. And before starting today's lecture, let me take a quick recap of what we have done in yesterday's class. So, we were discussing the topic link prediction. Okay, and in link prediction, we have covered three different strategies. So, the first one was local heuristic based link prediction, in which we consider the local neighborhood information. Okay, so in these algorithms, we basically see that how many common neighbors are there between two nodes. More the number of common nodes between two nodes, more is the likelihood that these two nodes will be connected. Okay, so there were various different types of algorithms we have seen in this category: local neighborhood, Jacquard, Adamic, Adar, and there were a few more. Okay, and the advantages of these algorithms are that they are fast, they are scalable, but the disadvantage is that they ignore the global structure. Okay, so then we discussed the next strategy that was global heuristic based. Okay, so in the global heuristic based strategy to find or to predict the links, we basically consider the entire networks. So in this, we consider all the paths of different lengths. So here we have covered different algorithms like cards index, then hitting time, commute time. These both were based on random walks. Okay, so we have discussed all these algorithms and we have discussed what are the advantages of global heuristic based method. The advantage is that these methods are more accurate as compared to the local methods. But on the other hand, the disadvantage is that these methods are slightly more computationally expensive. So the local methods are more scalable. They are suitable for large networks, whereas global methods, they are suitable for medium to moderate size of networks. Then the third strategy we discussed to identify the links was probabilistic based method. So in this method, firstly, we try to identify the hierarchical structures in the network. So these hierarchical structures were represented by using dendrograms. And in the dendrograms, we have something called as leaf nodes and internal nodes. The leaf nodes were the original nodes in the network, and the internal nodes were the nodes that represent that how two groups are connected. Okay, so then we have seen that each internal node was associated with a probability. So there was a probability associated to each internal node, and based on this probability, we can calculate the probability of a link. Okay, so yeah, so these were the methods that we have discussed in our last lecture. So in today's lecture, we will be discussing in detail the topic information diffusion. Okay, here it is wrong. So yeah, so we will be discussing in detail the topic information diffusion. So in information diffusion, we will be seeing that what all are the different ways in which we can model this diffusion of information in the network. So firstly, in the previous lecture, we have started with the introduction where we have seen that what is information diffusion. So information diffusion is basically study of how the information is spread in the network. Okay, so it could be fake news, rumors, or maybe some disease spread and so on. Okay, so we have seen what all are the different applications of information domain. And in today's lecture, we will be seeing how we will model this diffusion. Okay, so there are two types of model that we are going to study. One is decision-based diffusion model, and other is probabilistic based diffusion model. So we will be discussing decision based diffusion model in much more detail in today's lecture. And then in the next lecture, we will be discussing probabilistic based diffusion model. So probabilistic based diffusion model is again similar to what we have done in our previous lecture. So in previous lecture also, when we have probabilistic method for link prediction, we used to calculate the probability. Okay, so there is probability associated with each edge. Okay, and based on that probability, you can decide or you can predict the edges. So here also, like, we have probability of spreading the information. So we will be discussing these methods in more detail in the next lecture. Also, we will be discussing that what all are the advantages and disadvantages of these two models and how they evolve over time. So with that, let's start with some basic terminologies in information diffusion. Okay, so first of all, before discussing our topic for today, that is decision-based diffusion models, let's first go through certain definitions that will be helpful in understanding the topic. Okay, so the first definition is contagion. What is contagion? Contagion is an entity that spread across the network. So it could be a fake news, it could be a rumor, then it could be like, for example, COVID. So whenever we are discussing the epidemiology networks, it could be a disease that is being spread. So whatever is spreading in the network, that is called as contagion. Okay. Then we have adoption. Adoption refers to the event of infection or diffusion. Okay, so adoption is whenever like the information is spread and people accept it or adopt it, that is called as adoption. Okay, so it can be like people being affected by the COVID, or people they adopting certain products in the market. So these are the examples of adoption. Now, what are adopters? Adopter represents final set of infected nodes. Okay, so like in when information is spread in the network, certain people will be getting this information and certain will not be getting the information. All the nodes that get the information at last, they are called as adopters. Finally, what is cascade? The final propagation tree. So cascade is nothing but a propagation tree. Okay, so it is like how the information is being spread. So the final propagation tree obtained by the spread of infection is known as cascade. Okay, so for example, maybe like in this example, we start from this particular node. So this particular node, it spreads the information to its neighbors. So we can see that in the second figure, the information is being spread to these two nodes. Okay, so now after these nodes, we can see that these nodes, so this node, it spreads the information only to these nodes. Okay, they do not spread the information to these particular nodes. Okay, and yeah, so this becomes, as a result, this becomes your final tree. Okay, so this is your final cascade. It represents a tree where like all the nodes are infected or all the nodes have the information that is being spread. Okay, so now I hope the idea of diffusion is clear to you. What is diffusion in the network? And then we have discussed few basic terminologies of diffusion. Okay, so now I would like to ask you that can you think of some model of like diffusion, like how you will model this problem, the diffusion problem? Can you logically like explain me that how information is being diffused in the network?
Then we can make use of the structural behavior of that network like degree centrality. If the information is there at node A and A has
Mhm.
got a degree centrality, then the chances of it going from A to other people is very high. So the probability is very high. So that way we can think of modeling. Matlab we go to each node, find the degree centrality, or say another
Okay.
centrality measure, and then based on that we can calculate the probability and spread. That is one of the approaches we can take.
Okay. Sure. Any other, anyone else who want to try? Okay. So Rajneesh answered that it could be something that can be based on degree centrality. Okay, so yeah, degree is nothing but the connections of a node, right? So degree is like to how many other nodes a particular node is connected. Okay, so now if I try to like logically try to map this problem, so how can we solve this problem? So suppose I have a product. Okay, so suppose I have a product and I want to, make a decision that whether I should buy this product or not. So now what I will do, I will consider all my neighbors and I will see that who all have bought those products. Okay, and based on my neighborhood, I'll take a decision that whether to buy that product or not to buy that product. Okay, so yeah, so this is how like if there is some product in the market, this is how the diffusion happens. Okay, so firstly, the first idea is decision based. Okay, so in decision based, what a user is going to do, a user is going to see his neighborhood. Okay, so he's going to see his neighborhood and he's going to see that how many have adopted or how many have not adopted this particular product. So now based on the number of neighbors, also like that there will be some payoff. Okay, so whenever like there is a user, वो हमेशा अपना फायदा देखेगा. Like he will see what is like advantages to him. Okay, so yeah, so there will be a payoff associated with each deal, with each decision. Okay, so he will see that whether this particular decision is advantageous to me or not. Okay, so like suppose I have two options. Okay, so suppose I have two options. With each associated option, that is A and B, there will be something called as payoff. Payoff is nothing but a quantitative representation of the profit. This profit can be either monetary or it can be based on how much satisfaction you are getting, or it could be maybe the happiness you are getting. Okay, so payoff can be the measure of anything. Okay, so yeah, so with each decision you will have the payoff. So now your decision will be based on number of your neighbors that are adopting that particular product or that are taking that particular decision, maybe A, and also the payoff associated with it. Okay, and like there suppose there is another product B, so you will see the number of neighbors that have adopted B, and you will see the payoff that was associated with B. Okay, so this is a very high level idea of the decision based system. So in decision based system, what you are doing is you are seeing your neighborhood and you're also going to see the payoff. Okay, and combining these two entities, you will take the decision. Okay, you will try to maximize this function, that is the number of neighbors and the payoff. Okay, so you will try to maximize your profit by using these two variables, and then based on whatever is more profitable to you, you will take a decision. Okay, so this is one of the model. Then other model is probabilistic based. Probabilistic model. So what is probabilistic model? In probabilistic model, you don't have a control. So what do I mean by this? You don't have a control. In the previous model, that was decision based model, like you have the capability of taking the decision based on the payoffs. Okay, so you have the capability of taking the decision, but on the other hand, in probabilistic model, you do not have any control on the decision. Okay, but your decision will depend on some probability. Okay, so now this will be more clear if I give you the examples. So for the decision-based model, so whenever you are going to watch a movie or you want to be a part of the riots, okay? So in those particular situations, whenever you want to take the decision, you can model this problem using decision-based models. But on the other hand, whenever we are studying the spread of the disease, okay, so whenever you are studying the spread of the disease, you cannot really take the decision that whether you will get the infection or not. So it is probabilistic based. So in those cases, you are going to use the probabilistic model. Okay, so basically the probabilistic models are for like modeling your disease spread, and decision based models are when you want to take a decision that whether to buy a product, whether to go for a movie or not, whether to be a part of a riot or not, which political party you should support or not. Okay, so these all are will fall in decision based model, and the disease spread will fall in probabilistic model. So I hope these two models are clear to you at a very high level. Any questions up till now? Okay, so now we will discuss the decision-based model in detail. Okay, so yeah. So what is decision-based model? So given a network, each network has the freedom to decide whether to adopt a contagion or not. Okay, so each node will have this freedom to decide whether to adopt the contagion or not. Now, this idea originated from local interaction model. By local interaction model, we mean that we are going to see our local neighborhood. We are going to see the what all neighbors we have and what all decisions they are taking. So this idea is originated from local interaction model. Okay, so the decision at each node is influenced by the behavior of the nodes and its neighbors. Okay, so decision of each node is based on, like we have discussed previously, the decision is based on the behavior of the neighboring nodes. The nodes decide to adopt a new contagion driven by directed benefit or the payoff. Okay, so they are going to see the neighborhood and they are going to see payoff. So these 2 points are very important in decision based model. The payoff by adopting a contagion is directly proportional to the number of its neighbor that have adopted the same contagion. Okay, and can be explained using okay. So the ultimate goal of decision based model is to maximize. Okay, so we need to maximize our payoffs. Okay, so that is the ultimate goal of decision based model. So now, like from this slide, we should take away these few points. First of all, your neighborhood is important. Secondly, the payoff is important. And thirdly, what our ultimate goal is in this model? Our ultimate goal is to maximize the payoff function. Okay, so let me explain you payoffs in a little more detail. Okay, so for example, like I got this information that gold price will decrease by 20,000. Okay, so now like I want to take this decision whether to tweet this or not. Okay, so now there are payoffs related to this decision. So tomorrow, if like the news is true, then people might think that I have a lot of good connections through which I get such kind of information. On the other hand, if this information is wrong or if it is a fake news, then I might have to face embarrassment. Okay. So you can see that whatever decision I take, there is a payoff. The payoff can be positive and the payoff can be negative. Then I need to maximize the payoff. Okay. I need to maximize this payoff function. Okay. So I would like to give you one another example, for this decision-based model. So, for example, you have your mobile, and in the mobile, you want to install WhatsApp or Skype. Okay, so now your decision, you want to like communicate with your friends, and you want to take a decision that whether you should install WhatsApp or you should, install Skype. Now your decision will be based on like whether your other friends they have WhatsApp installed in their mobiles or not. Okay, so yeah, so the payoff will be like if you install WhatsApp, okay, so maybe you will be able to communicate with more number of friends. Okay, so that is a payoff. So now, like with this particular example, I hope you can visualize that how the number of neighbors as well as the profit that we are going to get or the payoff we are going to get is important to model this problem. Okay, so now if you understand these two terms properly, now let's try to quantify the payoffs in this model. Okay, so let us assume that A is installing WhatsApp and B is the decision of installing Skype. Okay, so yeah, so now you have these two nodes, U and V. Okay, now suppose A has already installed WhatsApp. Okay, so sorry, node V has already installed WhatsApp. And now if you also install WhatsApp, then the payoff is A. Okay, or the profit that you are going to get is A. On the other hand, if you have node V and node V has installed Skype, and you also install Skype. So you are going to get some profit that is associated by installing the Skype, and that is represented by B star. Okay, so this payoff can be anything. Maybe if you install WhatsApp, you are getting more speed. Okay, you are getting more buffer speed. But on the other hand, if you install Skype, so this is just an assumption. So if you install Skype, maybe there are more interruptions. So you have to quantify such situations. Okay, so there will be some quantitative or some numerical value associated with each of the decision here. Now suppose U was connected to V and V has installed Skype and U has installed WhatsApp. Okay, so if they both take opposite decision, then the profit will be zero. Okay, on the other hand, if you install Skype and if we installs WhatsApp, then again the profit will be zero or the payoff will be zero. So is this table clear to everyone? Any questions? Because like we will be using this table for further calculations. If there is any doubt, you can ask me now. Okay, so let's try to cover this slide. So A and B are the two strategies that each node in the network could adopt. So we have taken, for example, we have taken these two strategies. Each node U will pay its own independent game. Okay, so they have taken some example of game, and we have taken the example of installing WhatsApp and Skype. Okay, and like you are only going to get profit if your neighbors have also installed the same app. Okay, and that is quantified through these functions. Okay, so is this clear to everyone?
Ma'am, this A to B and B to A, the choice of zero is deliberate, or we can choose any other constant also?
Can you repeat the question?
Third and fourth choices, that is the
Hmm.
payoff choices for third and fourth, that is A to B and B to A.
Yes.
The value zero is deliberate, like if transition is not same, then we have to take the zero value, or we can take any other constant also.
Yes, we have to take zero only, Rajneesh. Why? Because suppose आपने WhatsApp install कर लिया, okay, and you have another neighbor जिसने Skype install किया हुआ है, तो आप तो उससे बात कर नहीं पाओगे ना. So there is no way of communicating. So in that case, the payoff will be zero.
मतलब स्प्रेड नहीं हो रहे हैं हम, तो दैट्स व्हाई वी हैव टू
Yes,
टेक.
yes, right, right, right. So you are only going to get payoff if you're going to take same decision as your neighbors. Okay. So now you know that there will be many neighbors. Okay, each node can have more than one neighbors. So now let us suppose that there were total d number of neighbors, and out of d number of neighbors, we have a fraction p. So fraction p have opted for a strategy, and rest of the nodes, that is 1 minus v. 1 minus p fraction of nodes have opted for B strategy. Okay, so this was a node. This is a node and it has various neighbors as we can see. So amongst these neighbors, let us assume that p fraction have opted for strategy A and p minus 1 have opted for strategy B. Okay, so now I want to quantify what will be the payoff of node U. Okay, so we are going to calculate what will be the payoff if like U decides to take you decides to adopt a strategy. Okay, so let me check what will be the function for this. So you know that let us assume that the payoff associated with a strategy is A. So we have seen in our last slide. So the payoff associated with strategy A is A, and payoff associated with strategy B is B star or B. Okay, so now if like A adopts, if node U, it adopts A strategy. Okay, if it adopts A strategy, so what will be my payoff function? My payoff function will be, so I will consider all its neighbor who are who are adopting A strategy. That will be D dot P. Okay, and what was the payoff associated with A strategy? Payoff was A. Okay, so this will be the total payoff function for if like U decides for A strategy. Now let us see what will happen if A decides for B strategy. So if A decides for P strategy, then we will see that how many numbers of node have taken the decision B or have adopted the strategy B. So the number of nodes that have adopted strategy B is D into 1 minus P. Okay, and then this we are going to multiply by the payoff for taking B decision, that is B. Okay, so this is the total payoff of for node U if he takes decision B. So is this are these two functions clear to you? Any doubt up till now? Any doubt anyone wants to ask? ओके, तो अब हमने देख लिया कि व्हाट इज द एडवांटेज और व्हाट इज द पे ऑफ दैट a user or a node U is going to get if he is going to take if he is going to adopt A strategy or if he is going to adopt B strategy. ठीक है, we have these two functions. Okay, now what will be the decision? The decision will be like whatever choice is giving us maximum payoff. Okay, so the user is finally or the node is finally going to take that decision. ठीक है, इन दोनों values में से जो भी value ज्यादा होगी that will be chosen by you as a strategy. Okay, अगर A बड़ा है A strategy will be chosen. On the other hand, if B value is greater, if like this value is greater, then like node U will choose B strategy. Now let us try to identify that what should be the fraction, what should be the fraction of the nodes if like if this function was greater. So let us try to identify that what will be the fraction, what should be the fraction of nodes if node U choose A as the strategy, okay? Or if the payoff function this was greater than this one, okay? So I want to quantify this. A dot D dot P is greater than B dot P dot 1 minus P. Okay, so in this case, like the node U has taken decision A. Why? Because this value was greater than this value. Okay, the payoff, the total payoff for selecting strategy A was greater than total payoff for selecting strategy B. So now in this case, I want to identify what will be the fraction of the node or what should be the fractions of the node. Okay, so this is, let me try to expand this, is greater than B dot D minus B dot D dot
How did
P.
we know that actually that A is greater than B here, ma'am, in this case? How
Uh,
did we come to a conclusion that actually, uh, I mean,
that
A
A
is
is
greater
greater
than
than
B?
B.
Yeah,
So this is an assumption here.
assumption.
So we
Okay,
have
okay, sure.
assumed कि okay, अगर A बड़ा है, अगर A बड़ा है तो fraction क्या होनी चाहिए? So this is
Mhm.
the question.
Okay.
अगर payoff by A is greater, then what should be the fraction of nodes? है ना? So this is an assumption and we are trying to identify the value of P. So if we cut the D value, so it should be AP plus BP greater than B. So here P should be greater than A plus B. Okay, so this is how we get this function. So is the calculation clear? Or do you want me to repeat anything?
It's clear, ma'am. Yeah.
Okay, sure. Okay, so this was like one of the perspective of this problem. Okay, so this was one of the perspective of this problem where you need to think, okay, we have to consider the neighbors and we also have to consider the payoff for each decision. Okay, and based on the calculation, whatever is maximum, whichever decision is giving us the maximum payoff value, that will be that decision will be taken by the node. Okay, so now this is another way of looking at this problem. Okay, so suppose I have this network, okay, and in this network, like I have node A, I, and G. Okay, so these nodes, so here like I have two strategies, one is A and another is B. Okay, so A strategy is that a person buys the subscription of Netflix, and B strategy is that a person buys the subscription of Prime Video. Okay, so these are the two strategies. Now, like we are going to consider the threshold for a switch from Amazon Prime to Netflix at the node is zero point 0.5. What do we mean by this? Okay, so for each node, we are going to consider its neighbors. Okay, and if like more than half of the people, or if more than or equal to half of the people have opted for Netflix, then we will change the subscription of that node to Netflix. Okay, so let me run through this example. So now let me consider node B. Okay, so node B has these two links. or two neighbors, out of which one is Netflix. Okay, so now what is the assumption here? If like more than or equal to 50% of the people have Netflix, then this node will also change his subscription to Netflix. Okay, so this node will change it to Netflix now. Let me change the color. So this will change its subscription to Netflix. Now let me consider this particular node. Okay, so if I'm considering this particular node, then this node has three neighbors. Okay, so amongst these three neighbors, only one has Netflix. So because only one has the Netflix, so that is why the subscription of this particular node will not change. Okay, so in this way we can check for each and every node. So now for H I'm going to see. So for node H, I have these two neighbors, and we can see that 100% of the neighborhood of node H is has like subscribed for Netflix. So because 100% of the neighbors have subscribed for Netflix, so this node subscription will also change to Netflix. Okay. So in this way, we will check for each and every node. So we will check for this node. So for this node, like only one neighbor is there and that is prime. So subscription will not change. Similarly, for this node, subscription will not change. Subscription will not change. Here we'll see here only one of the neighbor has a Netflix. So its subscription will not change. Okay, so after first hop, we have only these two nodes whose subscription has changed. Now from this particular network, now considering this particular network, we will again try to see the neighborhood of each node. Okay, so now if I consider the neighborhood of node C, okay, so let me see the neighborhood of node C. B has Netflix, J does not have Netflix, so its subscription will change. Okay, because 50% of the people has Netflix, so it will also change its subscription to Netflix. Okay, so now I'll check this node again. Its subscription won't change in this iteration for this J node. Okay, now like next I'll consider a K node. K node's subscription will also not change. Similarly, the subscription for these nodes will not change. And in the next iteration, so here one iteration is missing. In the next iteration, I'll have all these three nodes as Netflix, subscribed as Netflix, and all these three nodes subscribed as Netflix. Okay, so now after this, again, we are going to see the next iteration. So now when I see the next iteration, this particular node J has two of its neighbor who have subscribed for Netflix. So because it has two of its neighbors subscribed as Netflix, so its subscription will also change. Okay, so after some time, we will see that subscriptions stabilize in the network. So now we have this group which has Netflix and this group which do not have Netflix, which has Prime. Okay, so this is how the information is diffused in the network. Based on the neighbor, based on your neighbor's decision, your decision is impacted. And this is captured by decision-based cascade models. Okay, so now there is another perspective to this. So earlier we have seen that we have a node U, we have a node V. Now U had a choice. He can either choose strategy A or he can choose strategy B. Okay, so now let's try to look at this problem from multiple choice decision based cascade model. Okay, so let's try to see this problem from the perspective that a particular person can choose to have both the strategies. Okay, so I can choose to have both Skype and WhatsApp in my phone. I can choose to have both Netflix and Prime subscription. Okay, so what if, how we will, quantify or how we will model this multiple choice decision based cascade models? So in that, we are going to consider another choice where like a node U can take both the decisions or can adopt both the strategies A and B. Okay, so yeah. So in this model allows a node to adopt more than one strategies or behavior. In case a node prefer to go with both the strategies A and B, it would incur additional cost. Okay, so for now, let us try to again quantify the payoffs. Okay, so now let us assume these both were neighbors, U and V. Okay, so now V has already adopted strategy A. Okay, and node U has adopted both A and B. Now in this case, what will be the payoff? The payoff क्या होता है? Payoff is what your neighbors have decided. Okay, so it depends on what your neighbor has decided. So that is why the payoff for this decision will be A. Okay, so now let's consider the second option. Okay, your neighbor has taken the decision B and you have decided to take the decision A and B. Okay, or you have decided to opt for strategy A and B both. Okay, so now because your neighbor has opted just for B, so the payoff function will be B. Okay, so now in the third case, let us assume that your neighbor has also adopted the strategy AB and now you adopt for the strategy AB. Okay, so now if you adopt for strategy AB, then what will be the payoff? Payoff will be maximum of A and B. Okay, so it will the payoff in this case will be maximum of A and B. Okay, and we assume that whenever you are taking the decision of both the strategies. Okay, so for example, I am going to install both the apps on my phone, so there will be some cost associated with it. Okay, so there will be some cost associated with it that could be like the memory of the phone. Okay, so in this case we are going to subtract the cost. Okay, so this will be the total payoff for when like we are taking the decision AB. So is this table clear to everyone? So is this clear that how we will quantify the payoffs when like a particular node decides to take both the decisions? Okay, so now let's take a quick break of 10 minutes. Okay, and like I want you to revise these two tables, this table and this table. So let me check if I can paste these two tables in the messages. Okay, so I'll paste the two tables. Okay, so after the break, we are going to discuss few cases or few examples that will be based on these two tables. So in the break, if you get time, I want you to look into these two tables. And if you have any doubts, like after the break, you can ask, like if you don't understand anything from these two tables.
Ma'am, one question in the meantime. Ma'am, when will be the quiz to will be scheduled?
Second.
Second Monday it will open. Okay.
Yes, yes, yes.
And quiz one results are not yet out, ma'am.
Quiz one you cannot see till now.
Not yet.
Okay, I'll check the
Mm.
settings again because someone has raised the request and I remember I have changed the settings.
No, ma'am, not SMA.
Okay, so now only like in the break I'll change the settings. Just let me know if it is not visible, okay?
And one more last question, ma'am. For the EC3, it will be the portions will be from after mid-sem, that is seventh lecture onwards, or it will be full.
See, like majorly it will be from after midsem, but you can expect one or two questions from before midsem as well.
Okay. Thank
But
you.
mostly, the heavy proportion will be from after the midsem only.
Okay. Understood. Thank you.
Ma'am, one question. Is this necessary that the cost C will always be there and we need to reduce it?
Yes. So currently, like we have to take C as a cost here.
So practically,
So
what?
generally, when we are modeling some problem, okay. So whenever we are modeling a problem, we have to see कि उसमें क्या क्या और हो सकता है, right? And that modeling of the problem should be general. So generally, there can be a cost when you are taking the two decisions.
Okay. Okay, ma'am.
Yeah. So because these models are not for specific problems, so these models are constructed that it should be suitable for a large amount of problems, right? So you have seen that like we have problems for fake news detection, then rumor spread, and then there were other applications in this particular domain. So the model should be suitable for all those problems. So that is why we have to take C. And then like depending on your problem, if you have certain application, so if you understand this concept entirely, then maybe depending on your application you can modify the model. So that is what we do in research, right? So we try to modify this model and then we try to see that whether this works for this kind of data, this kind of situations or not.
Okay.
Yeah. Okay, so now we'll go for a break. We'll meet at 7 o'clock. Okay, so I hope now you are able to see the quiz marks, right? Can anyone check and let me know?
Yes, ma'am, we can see. Thank you.
Okay, thank you. Yeah, so we'll move back to our examples that we were solving before. Okay, so now see what we are trying to do up till now. We are trying to see that information, how information is being diffused in the network, or how a product is being diffused in the network, or how disease is being spread in the network. Okay, so basically, we are trying to model this situation. So now let us take an example of this chain network, okay? And like in this chain network, let us again assume that B is maybe like A is subscribing for Netflix and B is subscribing for Amazon Prime. Okay, so let us just assume that Prime came before. Okay, but like although I feel Netflix came before Amazon Prime, right? I'm not sure about that. But yeah, for this example, let us assume that Prime was something that people already had in their Prime subscription, most of the people already had. Okay, so yeah, so most of the people already had the Prime subscription, and there are very few people in the network who has Netflix subscription, and Netflix subscription is something new in the market. Okay, so now we are going to see that how this Netflix subscription is being spread in the network. Okay, so now for that we are assuming that payoff for Netflix is 3 and payoff for Prime is 2. Okay, so now let me try to compute this particular the payoff at each nodes in this particular network. Okay, so we had this network. This is A, B, and B. Okay, and we assume that the payoff for A is 3 and payoff for B is 2. Okay, so now let us try to find for this node. So suppose this node is U. Okay, so now what we are trying to identify, we have a node, we have for this node U, which already have Prime subscription. So it has two neighbors. So one of its neighbor has Prime subscription and one of the neighbor has Netflix subscription. Okay, so now I want to calculate the total payoff for node U. Okay, so now what I want to calculate, I want to calculate the total payoff at U. Okay, so first there will be two options. Okay, so since like here we are not considering multi-choice choosing the strategies, so there's only one option. Either you can choose for Netflix, that is A strategy, or it can choose for B strategy. Okay, so we have to calculate like what is the total payoff when you select A strategy and what is the payoff when you select B strategy. Okay, and then we will try to identify which one is the maximum value, and based on the maximum value, node U will adopt the new strategy. Okay, so yeah, so let's try to compute the total payoff at U when A was adopted. Okay, so if A is adopted, what will be the payoff due to this connection? So A has 3. So now here we are assuming that U has opted for strategy A. Okay, and this is B. Okay, so now in this, like because A has 3 and this also has adopted this this node, the node U has also adopted for strategy A, so it will be 3. So the payoff due to this particular edge will be 3 and the payoff due to this edge will be 0. Okay,
Ma'am, can I share the screen, ma'am?
My screen is not shared. Okay. Okay, so yeah, so we were trying to solve this question. So we were trying to identify the total payoff at U when you choose a strategy. Okay, so when you choose a strategy, we will see both its neighbors. So for the first neighbor, so this neighbor also has A and this also has A. So because of this, we will add the payoff here. That was 3. So now I'm considering this node and this node. Okay, so these both neighbors. So we know that this node has opted for B strategy and this node has opted for A strategy. So because it has opted, like the both have opted for opposite strategies, so the payoff will be 0. Okay, so the total payoff when you choose A strategy is 3. Okay, so now let us consider the second case. The second case is we are trying to find total payoff at U when strategy B was chosen. Okay, so now let me assume that U chooses B strategy. Okay, so now what will be the cost due to this edge? Anyone? What will be the cost due to this particular edge? This edge. This particular node has opted for A strategy, and this particular node U has opted for B strategy. So what will be the payoff due to this edge?
2, right, ma'am?
No, it will be 0. Total here
Oh,
will
okay.
be 2, but here because of this edge, it will be 0. Now I'm considering this particular node and this node, the node where I have written B. Okay, so now due to this node, you have opted for B strategy, and here also we have B strategy. That is why the payoff will be 2.
2.
Okay,
Yeah.
so now
Okay.
if I compute the total payoff when you choose B strategy is 2 here. Okay, so now amongst these two, we will see which one is maximum. Obviously, this one is maximum when he chooses A strategy. So now, this information will be cascaded here, and the strategy will be changed from B to A here at this node. Okay, so now similarly, we will calculate for other nodes as well. Okay, so yeah, so you can see in this example, okay, so earlier we were trying to see for this particular node, okay, so for this particular node, we have seen that what will happen when strategy A is followed and what will happen when strategy B is followed. So we have seen that when strategy A was followed, so that time the total payoff was 3. Okay, so since the total payoff when strategy A is adopted is more than the total payoff when strategy B is adopted, so node U will change its strategy from B to A. Okay, or in other words, I can say that it will change its, U will change its subscription from Prime to Netflix. क्योंकि पे ऑफ ज्यादा था, पे ऑफ मतलब उसका प्रॉफिट ज्यादा हो रहा है. Okay, so now similarly, we can calculate for all the other nodes. So you can see that similarly, we can calculate for all the other nodes. And for all the other nodes, A is being cascaded. The strategy A or the product A is being cascaded. Okay?
Ma'am, node U started from third one, right? Why is that,
Yes.
ma'am? Actually, I mean, why not from the beginning, ma'am? I'm just asking, right? I
So
think
this
maybe
is,
it's a given a problem.
this is an example where we are considering a chain.
Mm-hmm.
Okay, so this is a chain of nodes where maybe like all the nodes are connected. Okay, so and
Okay.
one of the node has already chosen the Netflix or A strategy, one or two nodes. Now we are trying to see that how this is propagated, whether this particular strategy is propagated or not. So the initial assumption is that we are having a chain network. So you could have chosen from here also. Okay, so here maybe on left side you have B and on right side you have B, and now you want to see that what this particular node, maybe let us assume that, sorry, is my screen on?
Yeah, yes, ma'am.
Okay, so you could have chosen to start from here or here or here. Okay, anywhere you could have started.
Got it, ma'am. Yeah.
So here the only aim is to see which node will opt for which strategy. Actually, this is an iterative process. At each step, we are seeing that what will be the strategy for each node. And the strategy for each node depends on its neighbors. Okay, so for each node, you are calculating depending on its neighbor, what will its strategy. Okay.
Yes, ma'am.
So eventually you will see that this A is propagated in the entire network. Okay, so now let us take the second example. So yes, anyone wants to ask anything?
Ma'am, in the previous question, this zero value has come because we had assumed that U was having B already. If we would have assumed that you didn't have anything and you have to decide whether to take A or B, then these
Mm-hmm.
weights half now. बिकॉज जो आपने जस्ट पहले जो बताया था कि टोटल डी आउट ऑफ डी नोड्स यू इज कनेक्टेड टू पी एंड वन माइनस पी ए एंड बी। तो अगर हम इस केस में देखेंगे तो इफ यू इज नॉट हैविंग बी, इफ यू अज्यूम दैट यू इज नॉट हैविंग बी एंड यू हैव टू डिसाइड कि ए चॉइस करनी है या बी चॉइस करनी है, देन एक्चुअली यू इज कनेक्टेड टू टू नोड्स ऑन विच हाफ इज ए एंड हाफ इज बी, तो ये सारी वैल्यूज हाफ हो जाएंगी।
Yeah, so that was another question that we were discussing, है ना? तो यहाँ पे कुछ half नहीं होगा, यहाँ पे it's like we are seeing two nodes. Okay, so वो जो question था उसमें it was explicitly given. So let me go back to that slide. Yeah, so
इससे पहले वाली स्लाइड, ये वाली, यस।
So what is your question? Can you repeat again?
कि जैसे जो नेक्स्ट स्लाइड में हमने कैलकुलेशंस में जीरो लिया है, दैट वी हैव टेकन बिकॉज वी हैड एज्यूम्ड दैट यू वाज ऑलरेडी हैविंग अ बी एज अ मतलब चॉइस, बट इफ वी से दैट यू at time given time t you didn't have any one of the options with it and now it has to choose a fresh,
Yes,
then ये वाला option will be played up where we say कि u is connected with two persons or nodes and it has got half choice, मतलब probability of half going there and half going there, मतलब proportion के हिसाब से हम देखेंगे, number of neighborhoods के हिसाब से देखेंगे।
हाँ, मतलब half we have to take these and half we have to take these. Like अगर मेरे पास two nodes हैं तो I will take the cost from both.
हाँ, and यहाँ पे zero is coming because u is already, it has selected B.
Yes, तो यहाँ पे जीरो क्यों है? क्योंकि उसने ये assume, like मैंने आपको वो solve करके दिखाया ना इस example में. So in one case we have taken कि U has chosen B. Okay, जब U ने B choose किया तो यहाँ पे cost था 0 and यहाँ पे cost था 2. जब U ने A choose किया तो यहाँ पे cost था 3 and यहाँ पे cost था 0. See, I'll explain again. I have these notes.
Yes, ma'am.
Okay. Let us name it as X, Y, Z now.
Yes, ma'am.
Okay. So we have this thing key this X node has strategy A and
Z has got
Z
B.
node has strategy B. The payoff for A is 2, A is 3.
Yes, ma'am.
And the payoff for B is 2.
2.
Okay. So now we are assuming कि node Y, if he choose strategy A. Okay, so what will be the total payoff? Total payoff will be due to this neighbor and due to this neighbor. Okay,
Yes, ma'am.
so what will be the payoff due to this neighbor? A, when we choose A and our neighbor also has A, so we have to take the payoff 3. Just a second, my pen stopped working. Just give me a moment.
Yes, ma'am.
Okay, so if Y, okay, so maybe like I'll explain without the pen. So if Y chooses A, okay, so I will have these two neighbors due to which my total payoff will be calculated. Okay, so because of X and Y connection, I'll have the value 3 on the left hand side, and on the right hand side, I will have the payoff 0. Okay, so if Y chooses strategy A, that is given here. So if Y choose strategy A, then we have 3 plus 0 as the total payoff.
That's what my question is. We are taking this 0 because we are assuming that Y already had chosen B.
No,
But it was in
no.
state B, that's why it is taking 0. If Y has to choose a fresh, then
Hmm.
the situation will be that वो जो आपने पहली स्लाइड में बताई थी कि a node has got few connections and probability of A connections and probability of B connections, and
Hmm.
accordingly इस केस में वो probability हाफ हाफ हो जाती है because सेंटर नोड के पास दो कनेक्शन है एंड हाफ ए के साथ कनेक्टेड है हाफ बी के साथ कनेक्टेड है देन
Hmm.
वेट बी 3/2 + 2/2 अगर
See,
वाई में ऑलरेडी इनिशियली बी पे नहीं है वाई तो बट जो हम स्लाइड्स में कैलकुलेशंस देख रहे हैं उसमें 3+0 इसलिए आ रहा है क्योंकि वाई ऑलरेडी बी पे खड़ा है मतलब वाई की स्टेट ही बी है मतलब इज दिस
huh,
द
in that particular picture, it is showing कि if like दो options है ना, या तो A choose करेगा या B choose करेगा.
हाँ जी मैम
Right, there are two options. तो उसमें उन्होंने पिक्टोरियली वो रिप्रेजेंट किया है जब उसने B choose कर लिया. अगर वो B choose करेगा तो क्या कॉस्ट होगी, that is being pictorially represented in that figure. So if we see this figure, so
यस
it is pictorially representing when strategy B was selected.
मैम
ठीक
तो
है,
वी वर
अगर
विद यू
हाँ, तो यू इसमें इसने एज्यूम किया है कि अगर यू ने आप इनिशियली ऐसे एज्यूम करके देखो कि बी के पास कुछ भी नहीं है, ना स्ट्रेटेजी ए है ना बी है, तो
हाँ
यू
जी
इज डिसाइडिंग नाउ वेदर इट हैज टू चूज ए और बी.
और बी
ठीक है, तो इनिशियली आप सोचो कोई कॉस्ट नहीं है, कोई पे ऑफ नहीं है, यू हैज टू फ्रेशली स्टार्ट एंड इट हैज टू चूज ए और बी. अब जब वो ए चूज करेगा तो आई विल हैव अ different total payoff. If I choose B, I'll have different total payoff. So whatever figure it is being shown here, it is shown that when U chooses B, so the cost will be on the left side, like I'll have zero, and on right side I'll have 2.
because it is मतलब the slide is saying मैम that stick with strategy B stick with strategy B means मतलब
No,
it
it
was
is not saying stick with strategy B.
ये first point it is written that way
We were solving this question, right?
first
So,
point if we
so here, like we can assume it like it is saying कि if strategy B was chosen, okay, so or if a person chooses, like if node U has B, like earlier हमने क्या assume किया था कि this was a network जिसमें only two nodes जो हैं वो strategy A में हैं, बाकी के nodes जो हैं वो they are following strategy B.
B
Okay, so now we can write it like ki, okay, that node U is sticking with strategy B, or I can say it in another ways that node U has chosen B strategy. वो similar ही हैं, there is no difference in these two. उसके पास ऑलरेडी बी था पहले, तो हमने बोल दिया कि लाइक वो उसी से स्टिक कर रहा है, या फिर मैंने बोल दिया कि ये जो नोड यू है इसने बी चूज कर लिया, अगर ये बी चूज करेगा तो क्या पे ऑफ होगा, अगर ये ए चूज करेगा तो क्या पे ऑफ होगा?
Okay.
I hope like I am able to clear your doubt.
Yes, ma'am. Clear.
Okay. So if there is anything else, we can discuss it offline, right? So
Okay.
yeah. So these are the two costs that we have. Now among these two costs, okay, one cost I have when strategy B was chosen, one cost I have when strategy A was chosen. So amongst these two, we will see that which one is the maximum value, and amongst that maximum value, like if like I have strategy B has A as maximum value, so then like the U will change its strategy, or it will switch its strategy to strategy A. So similarly, this particular strategy will be propagated in the entire network. Okay, so now I have this third question. Just a second, I'll connect my system again. My pen is not working. I don't know. Just give me a second. Okay, so now we have this second question. In this question, we have now multiple choice. Multiple choice ka matlab, like a node can either choose B, or it can choose A, or it can choose both A and B. Okay, so now like like I have already given you the example. A person can choose to have Netflix subscription, or like Prime subscription, or both the subscriptions. Okay, so AB is when the person is choosing both the subscriptions. Okay, so now in this case, we have a payoff related to A, that is 3, payoff related to B is 2, and cost when both is chosen is 1. Okay, so now in this example again, we will try to calculate for this particular node. Okay, so suppose I have A, then I have U, and then I have this node that has chosen B strategy. Okay, so now for I have three cases. The first case is when my node U, it chooses A strategy. Okay, so if it chooses A strategy, what will be the cost? The cost will be due to these two edges. Due to the left edge, what will be the cost? It will be 3. And due to the right edge, what will be the cost? Because I have opposite strategies, so it will be 0. Okay, so if I choose A, then total payoff will be 3 plus 0, that is 3. Okay, so now in the second case, let me assume that node U chooses B. Okay, so now if it chooses B, the total cost will be due to these two edges. Okay, due to left edge, I'll have 0 cost, and due to right edge, I will have payoff, that is 2. Okay, so we have these two payoffs. So when B is chosen, what will be the total payoff? 0 plus 2, that is 2. Okay, so now I have third option, that is when strategy AB is selected. Okay, so now let me assume when strategy AB is selected. So suppose this node U, it chooses strategy both A and B. Okay, so now what will be the cost due to this particular edge, the edge on the left? Anyone? What will be the cost due to this edge, A and U?
And the max of A and B, so it's 3.
Correct. And what will be the cost on a right-hand side? Max of AB and B, that is 2. Okay, here I have 2, here I have 2 and 3, so this will be 2. And we already know that the cost when both A and B are selected is 1. Okay, so this will be 3 plus 2 minus 1. That is 4. Okay, so now you can see that the total payoff, the maximum payoff, what was our aim, that the payoff should be maximum. For whichever strategy the payoff is maximum, we are going to choose that strategy. Okay, so because payoff for AB is maximum, so here we are going to choose strategy AB. Okay, so now let me take another example now. Okay, so now I want to calculate for node V. Okay, on left hand side I have AB. Okay, so on left hand side I have AB, then I have node V, and then on right hand side I have B. Okay, so now like node V has 3 options. One is A, another is when it chooses B strategy, and the third one is when it chooses AB strategy. Okay, so one by one, let us try to calculate for each of the case. So first case is when V chooses A. When V chooses A, it should be the cost due to this edge and the cost due to this edge. So what will be the cost due to the left edge?
It's a, can I say 3, ma'am?
3. Sorry. Okay. So, yeah. So we were doing this question. I don't know where it went. Okay. So we had this AB, V, and B. Okay. So now if like we had 3 options, A, B, and AB. Okay, so for first case, when like A node B chooses A strategy, so here we'll have, what will be the cost of left edge
3,
and what will be the cost of right edge?
0.
0. So the total cost will be 3 here. Now what about when we choose B? So the cost will be 2 plus 2.
4. Yeah.
So what will be the cost when like AB is chosen, the third case?
1 plus 2, 3, ma'am.
Okay, so when AB is chosen, the maximum value here is 3 and the maximum value on the right edge is 2. So this is 3 plus 2 minus 1. -1 is the cost when both ABA is selected. So this is again equal to 4. Okay, so now in this particular case, you can see that node V के पास he was already having B strategy. ठीक है, उसके पास पहले से B strategy थी. अब whatever options I'm having 3 options A, B and AB. Okay, so whatever options I'm having, मेरा cost मेरा payoff तो increase नहीं हो रहा. If I'm having strategy B or if I'm having strategy AB, in both the cases, we are having same payoff. So node B will not change. So node B will not change its strategy. Okay. So this particular trend, that is like people having both the subscriptions, this is not propagated in the network because payoff is not increasing. बिकॉज कोई फायदा नहीं हो रहा, दोनों सब्सक्रिप्शन लेके कोई ज्यादा फायदा नहीं हो रहा, तो व्हाई विल पीपल चेंज देयर स्ट्रेटजी? पीपल विल ओनली चेंज देयर स्ट्रेटजी इफ देयर इज सम प्रॉफिट. So here we can see that since there was no profit, no additional profit, so that is why the strategy is not being changed in the network. So is it clear to everyone?
Yes, ma'am.
Yeah. So, okay. So now again, we have this third case. So in the third case, we have A equal to 5, B equal to 3, and C equal to 1. Okay. So now in this case, we will see that how this changing these costs have an impact on the network. Okay. So first of all, we'll try to calculate the payoffs for this particular node, that is node U. Okay, so now if node U, it sticks with the B strategy, okay, or if it chooses B strategy. So what is the cost? Here we have A strategy, here we have B strategy. So the cost for B strategy is 3. So it will be 0 plus 3, that is 3. Okay, so now if let us consider the second case where node U, it chooses for strategy A. So if it chooses for strategy A, so here the cost will be 5, here the cost will be 0. So the total payoff is 5 plus 0, that is 5. Okay, so now let us consider the third case when we have the strategy AB at node U. So now I'll have these two edges or these two neighbors contributing to the total payoff. So on the left hand side, I will have cost as 5. On the right hand side, I will have cost 3 and then -1 for the, we have to subtract the cost, right? So the total payoff here is 7. Okay, so now you can see that whenever if the node it switches to AB strategy, then its payoff is increasing. So that is why we will switch the strategy here to AB. Okay. So now considering for node U. So similarly, like you can consider for other nodes. Okay. So for other nodes also, it will either be increasing or it will be decreasing. Okay. So now let me take the case here. So suppose I have AB here. Then I have a node V, and then on the right hand side, I have strategy B. Okay, so now in this particular case, so if I have 3 strategies, one is A, B, and C. So please compute the cost for each of these and tell me the answer. Sorry, here it is A and B. So quickly compute the cost for each of these cases and tell me. So do you have answers? Is this calculation clear to everyone?
Ma'am, it is clear, but I missed that last part, madam. Why we say -1, ma'am, for AB strategy?
-1 is the cost involved when we are choosing both the strategies. So if you are
Okay.
downloading both the apps, there will be some additional cost. Okay, so we are assuming that that cost is quantified by 1. So in the total profit, you subtract that cost.
Okay.
Yeah. So, okay. So again, we can see that for node B, the strategy changes from B to AB because payoff is maximum here, right? So now let us consider another case. Now let me consider for this node again. Okay, so suppose on one side I have A, then I have node U, and then on the other side I have AB. Okay, so now in this particular case, what will be the total payoff and what will be the strategy chosen? So I have these three cases. So if A is chosen, then it will be 5 plus 5. If B is chosen, it will be 3. If AB is chosen, it will be 5 plus 3 minus 1.
Why 3, ma'am? It's both sides you have A, right? 5 plus 5 minus 1, right? The last one.
Last one you're asking?
Yeah.
So if we are choosing AB, okay,
Hmm.
so on the left-hand side, it will be 5
5.
because
Hmm.
of A.
Yeah.
So on the right-hand side, okay, sorry, it will be 5. You're right.
Yeah. Okay.
So it will be maximum of A and B, like it should be 5. So this is 5 plus 5 minus 1, that is 9. Okay, so now there is one very interesting pattern that you can see here. Although like initially it started with AB strategy, okay? Initially, like the nodes changed from from B to AB, okay? But in next step, what will happen? They will change from AB to B, AB to A, because the payoff here is maximum. So, like I can map this to a situation or a real life situation. Let me think of an example. Okay, so it can happen that initially, like there is this there is this new product that is being launched in the market. Okay, so now people, like there are two products. Let us take an example of maybe like an Uber and Ola. Both are similar products. Okay, so this is again a hypothetical example. Okay, so these are two products in the market, and like let us assume that initially Uber was introduced. Okay, and all the people, they were like having this Uber app for booking the cabs. Okay, so now there is this new cab car app, that is Ola, that is being introduced in the market. So now very few people, they have this Ola installed in their mobiles. And you ask people, so what is the strategy? The strategy is that you ask people that please install this app as well, and you can try, you are getting so and so benefits and all. Now, like initially people had both the apps, both Uber and Ola. Okay, but eventually it might happen, if the quality of Ola is great, so eventually it might happen that people switch to Ola. So this can happen, and this is the pictorial representation or the quantitative representation of such a scenario. So this is how the behaviors get cascaded in the market, or the products get cascaded in the market. So if you have knowledge about this, this can also be used in the marketing strategies. So like in the next lecture, I will be discussing this in more details. So let me check if we have time. Okay. Okay. So I'll try to cover this one. So I'll try to cover as much as I can. So I hope like this cost calculation is clear to all of you and how the strategy changes based on the payoff values. So this understanding this concept is very important. Again, like in the exams you can be given a situation and you can be asked like how you'll calculate the cost of so and so node and what strategy a node can choose. So these types of questions can be asked. So all these concepts should be very clear to you, that like how the cost is calculated and how the strategy is changed in the network and propagated and what is the impact. Okay, so now the cascade in infinite chain network can be a generic model. Okay, so now let us try to quantify this in a generic model. So it is saying that we have the two cases. Okay, so now in this particular slide, what we are trying to do is we are trying to generalize whatever we have studied till now. Okay, so till now we have seen that there can be different cases. There can be different cases based on the multiple choice or the single choice. Okay, so they have now reduced it to these two cases. Okay, so this is a generic model, and in the generic model what you do, you consider one of the cost as one. Okay, so here what you do, the cost associated to decision B is considered as one. The other one, like the cost associated to decision A is considered as A, and the cost associated with decision C is considered as C. Okay. I think like it's better to discuss all this together. So I'll push this discussion to probably a next lecture only. So because like it will be half done and then like things will not be clear if I start discussing it right away. Okay, so with that, I'll quickly give you a recap of what we have done in today's lecture. Okay, so in today's lecture, we have tried to model the cascade effect in the networks. Okay, so for that, although we have two strategies. One is the probabilistic, one is the decision based. But we started our discussion with the decision based, and we started seeing that how based on the neighbors and based on the payoff values, your strategy or your decisions changes. Okay, so we try to quantify this into the model. So yeah, so and we have also seen that when is decision based model helpful, and we have also seen that when is your probabilistic model helpful. So generally when you want to choose among the products, or you want to take a decision that whether to go for a party or not, whether to go for a movie or not, so in those cases your decisions can be modeled by using decision based cascade model. But on the other hand, if you are quantifying the diseases, if you're trying to study that how diseases are spread in the network, what strategies to take in order to stop the diseases, so in those kind of situations, you will use the probabilistic model, which we will be discussing in our future lectures. Okay, so yeah, so I hope whatever I have discussed in today's class should be clear. I will share these slides, and before coming to next class, please revise up till here whatever we have done, and then we will try to generalize this model, and then like after generalizing, we will come to a very unique solution. We will try to conceptualize that how a new product should be launched in the market. So what should be the strategies that the companies can follow when they are launching a new product? Okay, so how the success rate of a product can be increased if we can follow those strategies. So those strategies are basically based on the networks. That is why understanding the networks and understanding these diffusion models or these mathematical models is very important. So if you have the understanding of mathematical model and how things propagate in the network, then you can take the better decision how to launch the product in the market. So yeah, so we will conclude all these things in the next lecture. But yeah, before going to next lecture, please quickly revise all what we have done in the decision-based model. So yeah, so with that, we will wind up our lecture. Any doubts anyone wants to ask? All right. So with that, we will end today's lecture. Thank you, everyone.
Thank you, ma'am.
Yeah. Thank you, ma'am.
Only that quiz one result should be enabled, ma'am. Uh,
Yes,
just a
yes.
reminder. Yeah,
Like
yeah.
someone confirmed that it is now visible in the
Oh, okay,
class.
okay, okay.
Yes,
Sure, ma'am.
yes. Yeah, you can check. Yeah. Okay.
Thanks, ma'am.
Thank you.